Hey guys, back with another video, Chapter 17, Temperature and Heat by me, Jan Philippe Ang. Okay, so a copper cylinder is initially at 20 degrees Celsius. So at what temperature will its volume be 0.15% larger than it is at 20 degrees Celsius? Problem 17.15 in your physics book, and we are given an initial temperature of 20 degrees Celsius, and we are required to look for T temperature when delta V over V is equal to 0.15% or is like 0.15% larger. So our solution, we have our equation for thermal expansion, and our 3 alpha or beta is our coefficient for thermal linear expansion. So for copper, that is 5.1 times 10 raised to negative 6. And we know that our delta V over V is equal to 0.0015 because that's 15%. So if you plug everything in, you get 0.0015 equals, that's supposed to be 5.1 times 10 raised to negative 6 times delta T will give you a delta T of 29.4 degrees Celsius. So we are looking for our T here. So we add the 29.4 with our initial temperature of 20, which will give you a final temperature of 49.4 degrees Celsius. Okay, so for our second number, you have 750 grams of water at 10 degrees Celsius in a large insulated beaker. How much boiling water at 100 degrees Celsius must you add to this beaker so that the final temperature of the mixture will be 75 degrees Celsius? Okay, so for our given, we have our mass of 750 grams, initial temperature of 10 degrees, a temperature of water of 100 degrees, a final temperature of 75 degrees. So for our required, we're looking for the mass of water, an M, where the water is 100 degrees Celsius, so that when added, our final temperature will equal 75 degrees Celsius. Okay, so for our solution, all we know that our heat energies should equal out in calorimetry. So we have in here we have the same C's, our coefficient, our specific heat rather. So we have 0.75 times 4,186, that's the specific heat of water, times 75 minus 10, which is our delta T, our change in temperature, equals M times 4,186 times 100 minus 75. So, once you isolate M, you will get an answer of a mass of 1.942 kilograms or 1,942 grams of hot water or water at 100 degrees Celsius should be added in order to get the system's temperature to 75 degrees Celsius. Okay, so for our last problem, an insulated beaker with negligible mass contains 0.250 kilograms of water at 73.5 degrees Celsius. How many kilograms of ice at negative 20.8 degrees Celsius must be dropped into the water to make the final temperature of the system 36.3 degrees Celsius total? This is 17.53 in your physics book. So we have a given of mass of water equals 0.25 kilograms, an initial temperature of 73.5 degrees Celsius, and a final temperature of 36.3 degrees Celsius. And we're required to look once again for the mass of ice at negative 20.8 degrees Celsius for the entire system, or the final temperature to equal 36.3 degrees Celsius. So, for our solution, we should note that ice and water have different specific heat values. So, and we also have to take into account the latent heat of fusion, because that's the value where ice melts. That's the amount of energy required for ice to melt. So we have our MC times 73.5 minus 36.3 equals our ML, that is your latent heat of fusion, your L, times MC, that is the specific heat of ice, the C, of 0 minus negative 20.8 plus MC, that is once again your ice, 36.3 minus 0. So your two values here are your ice melting from negative 20 to 0, and negative 20.8, and from 0 heating up to 36.3. So you get 0.25 times 4184 specific heat of water times 73.5 minus 36.3 equals, once you factor out your m, 3.33 times 10 to the fifth power, which is your latent heat of fusion, plus 2090 specific heat of ice times 20.8 plus 2090 times 36.3 will give you a final answer of a mass of 0.086 kilograms, or 86 grams of ice is needed to make your system, to turn your system to a temperature of 36.3 degrees Celsius. So there you guys have it. You have your mass of ice. So thank you guys for watching. Thank you for listening.